Okay, so graphing piecewise functions. Um, so what we're going to do here is first, I'm going to look at a word problem just because it helps explain piecewise functions, but we're not going to have to worry about solving word problems here. If you go ahead and move on to pre-cal and stuff like that, you'll probably run into some word problems. But here we go. So basically, a function that is defined by two or more equations is called a piecewise function. So it's just a bunch of functions broken into pieces. That's basically it. So here's kind of a word problem to kind of give you a better idea of how this works. So a cell phone company offers the following plan. $20 per month buys you 60 minutes, and then additional time costs 40 cents per minute. So after you surpass the 60 minutes, now you're paying an extra 40 cents per minute. And so this is the piecewise function down here. So right here, it's a flat rate of $20, whether you talk 0 minutes or 60 or anywhere in between. Once you go over 60, though, this is the new equation. You still have to pay that first 20, and then plus now you have to pay 40 cents times, and then t is the time that you talked on the phone. So obviously it's going to be over 60 if you're in this category, okay, if you're in this equation right here. So they'll subtract off 60 because you've already paid for it right here, that first 20, okay, and then they add on 40 cents per minute that goes over that 60. And then here's a picture of the graph of that. So right here, flat rate of $20 for the first 60 minutes, and then after that, then you start paying that extra 40 cents per minute. All right, so here we go. So for each piecewise function, find the specified function values. So we're not even going to graph them right now. Right now, we're just going to be finding the values, and then we'll graph them in a minute. So these are the parameters right here. These are the parameters for which equation to use, okay? So if the value that I'm evaluating is less than or equal to 1, then I plug it in the first one, the top one. If it's greater than 1, then I plug it into the bottom one, okay? So you never plug it into both, okay? Um, so on this first one right here, g of -4. So if I'm going to plug in -4, I got to figure out which one that belongs to. Um, and so I won't do this on every problem, but sometimes students might find it easy to make like number lines to kind of visualize your parameters. So this parameter is at 1, and then its values less than or equal to 1, so going that way. And so that would be a bracket, or you could do a closed circle if you want. This other one here is going to be from 1. It's going to be all values greater than 1, so it's going to go to positive infinity. So you use a parentheses. So if you look at -4 on the number line would be part of this blue one up here. And so we're going to plug in -4 into the top equation right here. So -4 plus 4, well, that's just 0. There you go. First one's done. Okay. The next one, let's see, we're going to do g of 0. So you look on your number line, where is 0? 0 is actually in the blue part again, right here. Okay. So we're going to plug it into the top one. So 0 plus 4, well, 0 plus 4 is 4. There you go, done. So it's not too bad. We've done this stuff before, just not with piecewise. So now we'll do g of 1. Oh, okay, interesting. So 1 kind of looks like it almost falls in both, but it doesn't. It only falls into one of these. And it's going to fall into the blue again because it says less than or equal to 1. The other one says it has to be greater than 1. So that's not part of the parameter right here of the second one. So once again, I'm just going to do 1 plus 4. So let's see, 1 plus 4, which is 5. Done. All right, last one. Let's see, g of 3. So this time, you can see g of 3 falls into the green category. So we'll plug in 3 here. So let's see, it's going to be 8 minus 3, which gives us a 5 again. All right. Okay, so that's with 2 of them. Now we'll look at it with 3. Okay, so it's going to be the same idea, except that now you got 3 to choose from. So you plug it into the first one if it's less than -5. If it's somewhere between -5 and 1, including -5 but not including 1, then you plug, well, this is kind of interesting. So your result's just 1. So, there's nowhere to plug it in, so it just defaults to 1. And then if it's greater than or equal to 1, then you plug it into this third one. So now you have 3 to choose from. So on our first one, let's see, h of -5. So let's see, -5 is not less than -5, so I can't plug it into the top one. So it's going to fall into this category right here. It's between -5 and 1, including -5. So that just defaults to a 1. That's it. It's just 1. Okay? H of 0. Well, if you look at your parameters, 0 falls into the middle one again. It's between -5 and 1, right? So it's sandwiched between there. So once again, it just defaults to a 1. All right. Let's see. The next one, let's see, we're going to have H of 1. Okay. This one does not fall into the middle because the parameter states that the value has to be less than 1. Okay, so it's actually going to fall into our third parameter because this is greater than or equal to 1. Okay, so we're going to go ahead and plug it into our last one right here. So that's going to be 1 plus 2. 1 plus 2 is 3. And then last but not least, let's see, H of 4. Let's see, nope. Let's see, nope, it's going to fall into that last category again. So greater than or equal to 1. 4 is greater than or equal to 1. So this is going to be 4 plus 2, which gives us 6. There you go. Okay, so not too bad. So as we move forward, we're going to start graphing these. Okay, so looking at this one right here, so it says the domain of each piecewise function is going to be from negative to positive infinity, so that means it's going to cover the whole graph from left to right, okay? So we want to go ahead and graph the function, and then use the graph to determine the range of the function. So after we find the graph it, we're going to go ahead and list the range. Okay, so the way this is going to work, I'm going to try to color code this so it's not too tricky, but what we're going to do is we're going to look at this first one right here. So I'm going to go ahead and call this y1. I'll call it my first one, right? So y1 equals 2x. Now, I only want to pick values that are less than or equal to 0. So we'll go ahead and make a little table here. Okay, and we're going to pick values that are less than or equal to 1. And you always want to pick the value that it bumps up against. So we do definitely want to pick 0 right here. So we're going to start with 0, and then just pick a couple values less than or equal to 0, like, you know, -1, -2. You know, we could keep going if we wanted to, but that's fine. So we're going to go ahead and plug it in here and multiply our x value by 2. So 0 times 2 is 0. Let's see, 2 times -1 would give us a -2. And then 2 times -2 would give us a -4. So I'm going to go ahead and plot these points. So 0, 0 is included. You'll notice that because it says less than or equal to. So I'm going to go ahead and just put a star next to that. You'll see why in a second. So I'm going to go ahead and put a closed circle there. And then let's see, we have another point at -1, -2. And then we have another one at -2, -4. And so I'm going to go ahead and draw my line so it looks something like that. That's pretty good. Okay. And then for the next one, let's see, we'll do this one in blue. Okay. So for this one, we'll call this y2. So y2 is equal to 2 right there if x is greater than 0. Okay. So when I make my table, okay, even though 0 is not within my parameters, I actually need to go ahead and start with 0, okay? And I'll kind of explain why in a second, okay? And I'm going to put a little star next to this also. So I do want to start at 0, and then I want to pick values greater than 0, like 1, 2. I could keep going, 3, 4, whatever you want to do. So I'm going to plug this in, and really there's nowhere to plug it in. It just defaults to a 2. So I get 2, 2, 2, and so on. Okay. So you're probably thinking, okay, well, how do I plot 0, 2? Because it's not included, right? But see, the thing is, like, you know, 0.1 is included, and 0.001 is included, and so on. I could keep, you know, adding zeros, and those points are included, right? Those are values greater than 0. 0 is not part of it, but it bumps up against it, and the way we indicate that it kind of bumps up against that point is we use an open circle. So at 0, 2, what I'm going to do up here is I'm going to actually put an open circle. Okay, and then I'm going to plot my other points, 1, 2, and then 2, 2. And so the idea is, well, I put an open circle there, and I'm going to go ahead and draw my line. And so the mistake a lot of times students make is that they accidentally start at 1. They accidentally start at 1, okay? And so they're missing all these values between 0 and 1, like the 0.1, the 0.001, and so on. And so that's why we always want to, you always want to start at these values, but just be careful for which one is included, where you're going to put a solid dot, okay, like we did down here in red. And then on this one right here, we had to put an open circle, okay? So you just kind of have to be careful. All right, let's try a couple more of these. So let's see here. Here are our parameters, okay? So once again, I'll just label this first one y1 equals x plus 3. And so we want to make a little table for when the x values are less than or equal to -2. I'm sorry, just less than -2. I'm sorry. But even though it doesn't have the equals to, that I do want to start at -2, and you can just put a little asterisk or star or whatever you want next to it, just to remind yourself to kind of think about, is it open or closed. And so then we want to pick a couple other values less than that. So you can just be boring. You can just say -3, -4. That's fine. Okay. And so we're going to go ahead and plug that in here and add 3 to it. So -2 plus 3 is 1. -3 plus 3 is 0. -4 plus 3 is -1. So I've got this right here. Oh yeah, so open circle at -2, 1. So I'm going to do an open circle. And then let's see, -3, 0, -4, -1. And then I go ahead and draw my line. There we go. So that's the first part. Second part, let's see, we'll do in red. So let's see, we'll call this one y2. So we'll have x minus 3. And so that'll be for when our values are greater than or equal to -2. It's jumping around. Let's see.